So thank you for joining me today and viewing this video on our cyanobacteria monitoring program for Vermont inland lakes. My name is Angela Shambaugh. I work with the Vermont Department of Environmental Conservation Lakes and Ponds program, and this is the training for 2018. Cyanobacteria is a name for a photosynthetic organism that's commonly found in our lakes and ponds, rivers, and streams in Vermont. You may recognize it by another name. They were also called blue-green algae. Cyanobacteria, however, is the more scientifically accurate name. It's the one that I'll be using throughout the presentation today. Large masses of cyanobacteria that either discolor the water or form surface scums are known as harmful algal blooms or sometimes harmful cyanobacteria blooms. So the name cyanobacteria is the more scientifically accurate term for these organisms because they are prokaryotes and more like other bacteria in their internal organization. They have no internal organelles, so there are no membrane-bound organelles within a cyanobacteria. There's no nucleus, there's no chloroplast. And this is in contrast to the other algae, which are eukaryotes, meaning that they do have chromosomes and nuclei and membrane-bound chloroplasts. Cyanobacteria are ancient. They are known as fossils. You can see a fossilized stromatolith shown on the image in the left. And these organisms are millions of years old and were first initially believed to be some sort of a geological phenomenon until someone found living stromatoliths in Australia. And that's the image that you can see on the right. Those rocks that you see in the view are actually these living cyanobacteria colonies. They've changed very little since the fossils were formed millions of years ago and remain highly successful. Cyanobacteria are very diverse. In addition to being found in freshwater environments, they can grow very well in extreme environments. They are part of the desert crust, which occurs in arid areas as one of the precursors to soil. They can form a symbiotic relationship with fungi and form the creature that we know as lichen. And finally, the image that you see on the right is an aerial view of Grand Prismatic Hot Springs in Yellowstone, and the colors that you see there are connected to cyanobacteria and other heat-loving bacteria that have organized themselves according to the water temperature that they prefer for their growth. So cyanobacteria are very diverse and they're found pretty much everywhere. They're beneficial to the environment. It's believed that the first organism to evolve the ability to conduct photosynthesis was a cyanobacterium. As a result of this ability, cyanobacteria became very successful. They did a lot of photosynthesizing and they produced oxygen as a byproduct of photosynthesis, and as a result our atmosphere changed from one that had very little oxygen in it to one that had a lot of oxygen. If that hadn't occurred, our Earth might look very different than it does today, and we as an organism, as humans and other mammals, might not be around. So as photosynthetic organisms, cyanobacteria are very important to lake food webs. They use sunlight and the dissolved organic nutrients and minerals in the water to create the products that they need to grow. In turn, those products are shared through the rest of the food web when the cyanobacteria are either eaten or decomposed during the decomposition process after they die. Cyanobacteria, some of them can also fix nitrogen, that is, they can take atmospheric gaseous nitrogen into their cells and use it for their own growth. And then again, when they die or are eaten, that nitrogen is available for other organisms in the lake food web. If you're a gardener, you're familiar with this process. Beans and peas as legumes also have the ability to fix nitrogen in their root systems. Scientists are exploring beneficial uses of cyanobacteria. Some scientists are looking at them as a source of biodiesel. Others are evaluating them for possible cancer-curing drugs and drugs for other human illnesses. Some scientists are investigating whether or not cyanobacteria can be a natural biofertilizer as well. And one that I saw recently in the news is that there are scientists out there also evaluating whether cyanobacteria might produce a natural sunscreen. So these organisms are native to Vermont. They're common, they're natural. So why are we actually here talking about them today? And that's because cyanobacteria in some cases can produce very potent toxins that are harmful to humans and to animals. Not all cyanobacteria are able to produce these toxins. They don't have the genes to do so. And even if they have the genes, those genes may not necessarily be turned on and producing toxins. It's not possible to look at cyanobacteria either with your eyes or under the microscope and tell that toxins are present. And we don't understand why toxins are present in the first place. We don't understand what the cyanobacteria uses them for. Because of this, we recommend avoiding contact with all cyanobacteria. You can't tell whether it's toxic by looking at it, so your best bet is to stay clear. So this slide from the USGS shows a little bit of about the kinds of toxins that can be produced by cyanobacteria. The first, hepatotoxins, are circled in blue. There are two main types, cylindrospermopsin and microcystin. Microcystin is one that is commonly detected in Vermont. And hepatotoxins are liver toxins. They directly affect the functioning and health of your liver. Neurotoxins, anatoxin and saxitoxin, are cyanobacteria toxins that affect the nerves. Anatoxin has been detected occasionally in Vermont. Dermatoxins affect the skin. They can cause things like skin irritation and rashes. And finally, cyanobacteria are also known to cause taste and odor problems. So drinking water operators have been paying attention to them for many years. The four genera shown on the slide, Anabina, Aphanizomenon, Microcystis, and Oscillatoria, are all found in Vermont. They're some of the more common cyanobacteria genera in North America. And you can see that some, like Anabina, can produce more than one kind of toxin. Others, like Microcystis, are only known to produce one. So again, you can't tell whether a cyanobacteria bloom is toxic by looking at it. So in order to stay safe, we recommend that you stay clear of them. Symptoms of exposure in people include rashes and skin irritations, allergy-like reactions like runny nose or sore throat, stomach problems like diarrhea or vomiting. There can be liver damage in cases of severe exposure or extreme sensitivity. There's numbness in fingers and toes, dizziness. And these are potent toxins. If you get exposed to enough of them, they can cause very serious illness, and in some cases, you can die from your exposure. It has happened occasionally in humans, but that is very rare. Pets and livestock, on the other hand, are much more likely to be seriously affected by cyanobacteria toxins. It's because they tend to drink a lot of water at any one particular time if they're thirsty, and they don't necessarily care what that water looks like. So they can ingest a large amount of cyanobacteria as a result. Symptoms in pets and livestock include weakness, staggering, difficulty breathing, convulsions, vomiting, and diarrhea. It's not unusual to hear in parts of the United States that there have been dog deaths associated with consumption of cyanobacteria. So who's at greatest risk? The most vulnerable are small children and pets. And again, this is because they are not very concerned about the water that they're playing in or drinking. Small children are very likely to put things in their mouth or swallow a lot of water when they're swimming. Pets, again, aren't really particular, and if they're anything like my dog, they actually like to eat the things that are really not appealing. And so as a result, they are much more likely to get a large amount of cyanobacteria. For adults, the highest risk comes when you're in contact with or swallowing water that contains large amounts of cyanobacteria. So if you're swimming or snorkeling, if you're jet skiing or water skiing, you may come in contact with cyanobacteria through those activities. We very strongly recommend that you avoid swimming in water that looks like the one in the image there in the center of the screen. That's a large amount of cyanobacteria, and your chances of becoming ill are significantly increased by coming in contact with water of that color. Conditions that encourage growth include heat and nutrients. Here in Vermont, we're most likely to see cyanobacteria blooms, which are these large accumulations of cyanobacteria that either discolor the water or form a scum at the surface. We're most likely to see them when the water is warmer. So for us, that's typically from mid-July to mid-September. That doesn't mean you can't have blooms before then or after then, but most commonly that is when we see our blooms here in Vermont. There are species of cyanobacteria that will grow and bloom under the ice. but in most cases there's not a lot of people out there recreating, so we don't get a lot of reports of that in Vermont. Nutrients are important for growth of all living creatures. We need food, so do cyanobacteria. Their food is primarily phosphorus and nitrogen. In order to grow a large number of cyanobacteria cells, you need to have a large amount of these nutrients. We tend to find our worst blooms, those that are the densest, the thickest, and the most long-lasting, in our lakes that are nutrient-rich. So by controlling the amount of nutrients reaching our water, we can significantly reduce the occurrence of cyanobacteria blooms. And then the final thing that doesn't really encourage growth but determines where we see cyanobacteria in the water column is their ability to regulate where they are in the water. They have small gas vacuoles, small air bubbles within their cells, which they can use to determine how high up in the water column they want to be. Because they're photosynthetic organisms, during the daylight they typically want to be up near the top of the water where they can get the best sunlight for photosynthesis. At night they may drop down into deeper water or even all the way down to the bottom, because that's where they can find the most nutrients. So we can see cyanobacteria forming scums at the surface, as you see here in this milk bottle, because of that ability that they have to regulate their buoyancy. They are very small, so this typically occurs under calm weather conditions. If there's a lot of waves or a lot of currents, they're not able to counteract that, and so they will be distributed through the water rather than associated in a scum at the surface. Reducing your chance of becoming ill from exposure to cyanobacteria is all about risk management. We practice risk management every day without even thinking about it in many cases. None of us really hesitates to get into our car, get onto the interstate and drive 65 or 70 miles per hour. And that's because we've taken a lot of steps to reduce first our chance of having an accident, and then reducing our chance of serious illness if we do get in an accident. We have driver's licenses, right, so that everyone knows the rules of the road. We have signs and stoplights to regulate the flow of traffic, and then our vehicles are built very sturdily. We have airbags, we have seat belts, we have reinforced frames. So we do a lot to make sure that our risk of being injured in a car is minimal. If you grew up in tornado country like I did, you recognize the weather that might lead to a tornado, and you know what to do if you see one. You wear your life vests out on the lake. You know what to do if you're out on the ice during the winter. And most similar to cyanobacteria, we use a lot of toxic chemicals in our homes, but we don't think about that very much because we read the manufacturer's instructions and we practice safe use of these products, and so avoid illness that way. And so our goal with cyanobacteria monitoring is to provide people with the tools that they need to reduce the risk of coming in contact with cyanobacteria. This data is from Lake Champlain in 2017 and the years prior to that. And I want to draw your attention to the bars, which are the number of cyanobacteria reports provided each summer as part of our monitoring program. The generally safe conditions shown in green are those conditions where very few cyanobacteria are present and there's little risk of exposure during recreational activities. The red and the yellow indicate higher risk, and the takeaway message from this slide is that 90% of the time during our monitoring period each year, we see that conditions are considered safe for recreation. There are very few cyanobacteria present. There are some locations on Lake Champlain that clearly have more cyanobacteria blooms than others, but in general on Lake Champlain and most inland lakes during the summer, cyanobacteria are not a risk or concern for human health. This slide shows some of the other inland lakes that we've monitored in the last few years. On the left side are Lake Carmi and Shelburne Pond. You can see that their cyanobacteria are much more abundant. You're more likely to experience a bloom or see a bloom in that on those locations than you are, say, on Lake Memphremagog, on Lake Iroquois. The number of blooms reported each year is very much influenced by weather patterns and prevailing environmental conditions, so you can see there is a lot of variability from year to year. And not only does that variability differ from year to year, it can differ from lake to lake. The two bottom panels of this graph, Missisquoi and St. Albans, have their cyanobacteria blooms typically earlier in the summer than Lake Carmi does, for example. So as you monitor, you will become familiar with your lake, and you may find that you have no cyanobacteria at all during the summer when you're monitoring, or at other times you'll find that it may be present only on certain occasions. So the goal of the Cyanobacteria Monitoring Program is to quickly share information about conditions of concern. You as a monitor will assist us to gather data about those conditions on our Vermont inland lakes. And by using this monitoring system that I'll introduce you to shortly, you'll be able to provide consistent monitoring reports, and we can then provide consistent response to cyanobacteria blooms across the state. And the other goal of using this system is to help everyone to recognize cyanobacteria wherever they occur. Environmental conditions can change very rapidly, so a cyanobacteria bloom can be visible at one moment and gone the next. By helping everyone recognize cyanobacteria, you can make a decision about the water that you're getting ready to go swimming in, wherever you may be with minimal equipment. So as a volunteer, we'll ask you to agree to monitor a single site or more if you have time over the course of the summer. In 2018, we started monitoring the second week of June and we'll end the first week of September. If you happen to be around longer than that and would like to monitor longer than that, we will be happy to take your reports. The Cyanotractor map is often active into October. So we'll ask you to choose a date and a time and make your observations between 10 a.m. and 3 p.m. Cyanobacteria blooms at the surface are more likely to occur at that between those hours, and so that's why we ask you to make your reports then. We'll ask you to post your observations on the Cyanobacteria tracking website. If you have difficulty accessing the internet or prefer another method there, we can also find other options to get your information to us. So your protocol, again, is to go to your site each week, preferably on the same day and time, and that allows you to avoid selecting good conditions or bad conditions. And again, you'll make your observations between 10 and 3 p.m. You'll use the visual assessment protocol to evaluate the amount of cyanobacteria that are present at that particular time, and then you'll report what you see through our online reporting form.